This is AP Calculus Lesson 4-5, Taylor and Maclaurin Polynomials. Today's date is Wednesday, April 1st, 2020. So our objective today is to find Taylor polynomials of functions. And here is a seemingly complex formula that I don't want to dive in too quick. I want to show you a cool little party trick first. So let's say I have some function cosine of x. I will be able to recreate this function with a polynomial. That means something with x to the power of 3, x to the power of 4. But how do I get a trig function from a polynomial? That seems impossible at first glance. Well, let me show you that. So let's say y is equal to 1. Okay, you might be looking, okay, that doesn't look very good. I can make it better. I can subtract x to the power of 2 divided by 2. Oh, it looks a little bit better for that part. Let's make it even better. X to the power of 4 divided by 4 factorial. Ooh, even better. Minus x to the power of 6 divided by 6 factorial. Ooh, even better. Plus x to the power of 8 divided by 8 factorial. Wow, even better. And you can probably guess what's going to happen next. X to the power of 10 divided by 10 factorial, etc., etc. If I can do this for an infinite number of terms, then it will be exactly equal to cosine of x. And there's a bit of a line there, but it's enough truth to satisfy, like, this will eventually go out towards infinity in both ends. It will approach the actual cosine wave very slowly, but you can see, at least for the interval between negative pi and pi, it's almost exactly the same thing, just with a bunch of x's without using any trigonometry, which is pretty impressive if you ask me. So very cool. How did I do that though? I'm going to reveal my magic trick to you guys. It's using a Taylor series. So here's our formula. It basically says if I want to create a function that is based on a polynomial that can be given by taking the sum of this thing. So when I have parentheses up here, this means to the power of. There's no good notation of saying take the derivative 100 times. So if this right here is 100, if I do 100 in parentheses, that means I'm taking the derivative 100 times. And if you think about it, that can be really complex depending on the type of function. It might get really, really big. And then a is just a value that I'm evaluating around. So in my example back here, I was evaluating around this point. If I move this point to left and right, then it would be very accurate around this point. My Taylor polynomial is really a Maclaurin polynomial, is very accurate around x is equal to 0. So my a in this case is 0. And then I have to divide by n factorial because of I have the reason. Khan Academy does a good job explaining why you have to do this. It comes from taking the derivative over and over again and canceling out your coefficients. And then this is going to tell you where to center your polynomial as well. So you'll always have some sort of x minus whatever your coordinate is. I just did x minus 0, so I just had x squared, x to the power of 4, x to the power of 6. I didn't have to do any minus a's inside my parentheses, but I totally could have. So this is a more condensed formula, but what's helpful for me, at least when I was learning this for the first time, was looking at its expanded form to see the patterns. What are you really doing? So the first term that you're going to be getting is plug in whatever you're centered around. In this case, a is your center, right? So can we all write in this in our notes too? This is where are you centered around? The center is a, and n is just which term am I talking about? So this is the term. This is the index, right? The first term, the second term, the third term. How many terms are going to go out to? So just plug in your center into your function. What does that leave you with? Again, I'm giving you some function like sine of x or cosine of x, right? So plug in that number, and then that's the first term. The second term, first take the derivative, then plug in the number, which we know how to do, and then just multiply it by x minus whatever that center was. Then the next thing that I have to do is I need to take the derivative twice, plug in my number, and then divide it by 2 now. Really, back here I'm saying 2 factorial. 2 factorial is equal to 2 times 1, which is, again, just 2. So I simplified it here. Really, back here I was dividing this by 1 factorial and dividing this by 0 factorial. By the way, 1 factorial, as you might guess, is just 1 times 1, or just 1. And 0 factorial has a very special meaning. It's always 1, and the reason that we define it this way is it makes the math work. It's kind of a funny definition, but 0 factorial is 1. So there are hidden factorials back here that I'm not writing down, but they are still there. And then you keep doing this as many times as it takes. The more of these terms that I have, the more accurate you will be. And you saw that in this case over here. If I have less and less terms, if I get rid of those terms, I'm not as accurate. In fact, if I go all the way back to this first term, it's really, really bad. So the more terms you have, the more accuracy you have. So I've been talking about a Taylor series or a Taylor polynomial this entire time. What is a Maclaurin series? And I'm only 50% sure it's pronounced Maclaurin. Maybe I should look that up. Is it Maclaurin? Maclaurin? I should definitely know this, but it's even easier. It's whenever it's the same as a Taylor series, but a is equal to 0. They chose it for us. They're centering the x coordinate at 0. They've chosen this value of a, so this goes away. This is always 0 on the inside. It makes it a lot simpler, which is nice. So there it is. Let's try using this math. So find the first 3 non-zero terms in the Maclaurin series of this function cosine of x. And hey, I just did that back here, but haha, I deleted all my work. You don't know what it was. You know the first one is 1, but how did I get that? So I'm revealing the magic trick, as I said. So I have cosine of x, so my formula says, hey, just plug in whatever you're centering at. Maclaurin series says I'm centering it at 0, so plug in 0, and that is going to be my first term. Maybe it would help to write out the formula again. This is equal to f of 0, because my a is 0 in this case, and then this is going to be plus f prime of 0 times x minus 0. Well, it's kind of silly to say x minus 0, so I'm just going to write x. And again, these two are being multiplied by each other. And I'm going to say plus f double prime of 0 of x minus 0. That doesn't make sense. I'm just going to write times x squared. And that's all divided by 2. And then plus f to the power of, or not to the power, there's 3 derivatives happening here. Still plugging in 0. Now x to the power of 3 divided by 3 factorial. And I don't know how many terms we're going to have to go out to, but if I get a 0 term, that doesn't count. I'm only counting non-zero terms. Let's go ahead and start taking the derivative. The main thing to take away from this lesson is you're going to be doing lots and lots of derivatives. If you haven't mastered derivatives, you might need to go back to Unit 2 to review some stuff. So first, just plug it in, no derivatives. If I plug in 0 into my function is cosine of x, cosine of 0, I'll do some scratch work off to the side. Cosine of 0 is equal to 1. It's just a definition that you need to know. Again, if I'm looking at the unit circle, 0 degrees is right here. Cosine is the x-coordinate. X-coordinate is 1. That's a distance of 1. All right, so is equal to 1. And hey, that's what I did right here, 1. All right, what's the next term? So this is going to be plus. What's the derivative? What's the derivative of cosine? And then I'll plug in 0 after that. So again, more scratch work off to the side. What is dx of cosine of x? Well, the derivative of cosine is, you have to change it, right? So it's negative. Oop, what happened to my mouse? It stopped moving. Whoa, okay. It's negative sine of x. Perfect. All right, so that's the derivative, and it says plug in 0 now. Plug in 0 into that x right there. So sine of 0 is 0, so negative sine of 0 is negative 0, or just 0. So darn, this term right here went to 0 because it was sine. All right, well, on to the third part. This third term, I take the derivative again. So let's take the derivative of this term again. So I'll write over here to give some more room. So the ddx of negative sine of x is equal to, well, the derivative of a sine is cosine, and I just copied down that minus. So negative cosine of x. Cool. That's what the second derivative is. Now it says plug in 0. If I plug in 0, cosine of 0, as we saw up here, is 1. So the answer here is going to be negative 1. I have that negative out front. So this f double prime of 0 is negative 1. So I have negative, and then this right here, x squared over 2, minus x squared over 2. And if you remember from the video, I guess you could just rewind this on YouTube, right? And so this is minus x to the power of 2 divided by 2. it got even more accurate. All right, what can I do next? I'm going to take the derivative a third time. So again, more scratch work. Dx, the derivative of this negative cosine of x. Negative cosine of x. Well, the derivative of cosine is negative sine, so a double negative is going to be positive sine of x. And I'm going to plug in 0. Plugging in 0 gives you 0 again. So these terms kind of cancel out because the derivatives was sine. Notice that I haven't hit 3 non-zero terms yet. I've hit 1, 2, and then finally this next one, I have to write down f. And I can do 4 in parentheses because I'm taking the derivative 4 times, and it's just a quick way of writing the 4 little dashes or tick marks, whatever you want to call them, primes, x to the power 4 all over 4 factorial. And all right, taking the derivative yet again. The derivative of sine is cosine. Dx, the derivative of sine of x is cosine of x. And cosine of, I forgot the 0 over here, didn't I? Oops. I'm plugging in 0 still. So plugging in 0, cosine of 0 is 1. So this right here is just 1, which means the answer is just x to the power 4 over 4 factorial. So plus x to the power, I guess I should say plus 0, and then plus, all this stuff needs to be moved down. I'm running out of room. Grab all of you, move you down. This is going to be plus x to the power 4 over 4 factorial. And done. So if I want to simplify this a little bit, 4 factorial, I can leave that as 4 factorial, or I can say 4 factorial, this is equal to 4 times 3 times 2 times 1. 4 times 3 is 12, times 2 is 24, so that denominator is actually 24. The answer here is 1 minus x squared over 2. I'll leave it unsimplified and simplified, x to the power 4 over 4 factorial. I'm just going to leave it like that. I'm lazy enough, and I think Khan Academy is lazy enough too to not actually calculate what that is out. Cool, done. Let's try another example. It's phrased a little bit different. It's not looking for non-zero terms. Example 2, we're just finding the second degree Taylor polynomial centered at 9. Okay, so our center is different now. Before our center was 0 because it said Maclaurin series. Now our center is 9. And we have a different function, of course. So second degree means I'm going all the way out to the x squared term. Once I hit this squared term, I'm done. So I'm kind of cutting it off right there. Again, I'm going to kind of write out my formula here. It'll help me. So this is going to be f of, and then plug in the number, f of 9. And then that is a 9 plus, and then I'm going to take the derivative f prime of 9. And then I'm going to multiply that by x minus whatever that center is times 9. Okay, and then plus f double prime of 9 times x minus 9 again. All of that squared. Again, this is just going to go squared, then the third power, then the fourth power, etc., etc. But I have to also divide by whatever this exponent is, factorial. So divide by 2 factorial, which is just 2, because 2 times 1 is just 2. All right, so there's our formula, and we need to start finding the derivative. I need to find the derivative and then the second derivative. Those are the 2 hardest steps now after writing down my formula. So I know f of x, that's pretty straightforward. When I plug in 9 into f, that's going to be the square root of 9 divided by 3, or 3 over 3, and 3 over 3 is 1. So this is equal to, we'll leave it as just 1. I think you guys can follow along. If I plug in 9 into here, I get 1. Next, let's take the derivative of this function, the square root of x over 3, and see what happens. Then we'll plug in 9 afterwards, right? So we'll say f prime of x, that's going to be equal to, well, I used to have, maybe I should write down what f of x was with exponential notation instead of radical notation. So f of x, before I took the derivative, was not square root of x, but x to the 1/2 over 3. And if I take the derivative means this 1/2 comes down in front. So this is now a 1/2 x, and then go down a power. So to the negative 1/2, and then that's all over 3 still. And I need to simplify this a little bit. So I still have the 1 over, it's really 1/6 now, because divided by 2 and then divided by 3 is the same thing as divided by 6. And this negative 1/2 means it's really in the bottom, so it's going to be the square root of x, or if I'm skipping too much, this is x to the positive 1/2, which is just going to make that a square root, right? Anything to the power of positive 1/2 is just square root, so 1 over 6 square root of x. So that is the second derivative, and it says, okay, now plug in 9. Plug in 9 into that first derivative. When I plug in 9, this is now going to be 3. 3 times 6 is 18, and that's 1/18th, which means this right here says 1/18th, and I still have to write down this. So I'm going to say plus x minus 9 over, I don't know why I put parentheses there, x minus 9 over 18. Done. All right, now I have to take the derivative yet again. I'm going to kind of take the derivative, not of this form, because I don't like taking the derivative with radicals. I'm going to take the derivative of this form, which is 1/6, still out front, x to the power of negative 1/2. Let's take the derivative of that. So f double prime is going to equal, I guess I should say f double prime of x is going to be equal to, okay, this negative 1/2 comes down in front. Negative half times 1/6 is negative 1/12, so negative 1/12. And then it goes down a power, so it's now x to the power of negative 3/2. Okay, so there is the derivative. Let's go ahead and make it usable now. So this is still negative 1 in the numerator, so negative 1 in the numerator, and in the denominator we have 12 still, and this negative power is going to come down to the denominator and become a positive power, so it's x to the power of positive 3/2, or if you prefer, this is negative 1 all over 12 times the square root of x, and then I'm going to take that to the power of 3. All right, so again, I just found the second derivative. Now I need to plug in 9. Plugging in 9, the square root of 9 is 3. 3 to the power of 3 is 27. Oh my gosh, this is big. And 27 times 12, 27 times 12, that's the denominator. I'm just going to cheat. I'm going to use a calculator. If my Spotlight search would work, 27, that's not 27, 27 times 12, 324, youch. So this is 1 over 324, but we also have to do the divide by 2. So if I'm writing out my work, I have 1 over 324 times that 1 over 2, that 2 is in the denominator, and then this is still times x minus 9 to the power of 2. And again, I just need to simplify this to double the denominator essentially. So I have 1 plus x minus 9 over 18 plus 1 over 648. Oh, I should just put the x minus 9 squared in the numerator. So this is x minus 9 quantity squared in the numerator. And done. That is the second degree Taylor polynomial, because we went out to an x squared term. This 2 means second degree. If I wanted a third degree, I'd have to go out to the third power right there. And I should box this final answer. Whew, all right, example number 3. Oh, it tells us the derivatives. Oh, this is going to be way easier. So it tells us the derivatives, and it's asking for the first 4 non-zero terms of the Taylor series centered at x is equal to 2. All right, well, the center is a little bit off. It's not at 0, so it is Taylor. Let's go ahead and write out the formula once again. You should practice writing out the formula because you're going to have to memorize this thing. It's first going to be f of a, and a is 2 in this case, so f of 2 plus f prime of 2, and divide by 1 factorial, so don't have to worry about it, times x minus 2 plus f double prime of 2 times x minus 2 squared all over 2. And then finally the fourth term, again I did 1, 2, 3, and now the fourth term, and I'm asking for the first 4 terms, hopefully this will be the last one, is f to the 3 primes of 2 times x minus 2 to the power of 3, all of this divided by 3 factorial. All right, time to start plugging things in. f of 2 is 1. It tells us to write that right here. F of 2 is -1, so this is -1. Perfect. Plus, it says f prime of 2 is 3. So f prime of 2 is 3, so 3 times x minus 2. Done. All right. Plus, it tells us f double prime of 2. This f double prime of 2 is 4, so plus 4 times x minus 2 quantity squared over 2. Eventually, this 4 and 2 will cancel out. I'll write that simplified on the next line. And plus 12, because f triple prime of 2 is 12. It tells us that right there. Times x minus 2 to the power of 3 all over 3 factorial. Cool. Whenever you have a factorial, I think I'm just going to leave it like that. I don't want to multiply out 3 times 2 times 1, although that's 6, and 12 divided by 6 is a nice number. Whatever, I'm going to leave it like that. So my final answer, do it in red, is -1 plus, I'm just going to rewrite that. You could distribute the 3, dealer's choice at this point. I'm going to leave it like this because it's easier to see the form. I am going to simplify this one, plus 2 times x minus 2 squared plus, I'm debating, maybe I should simplify this. 3 factorial is 3 times 2 times 1, which is 6, and then 12 divided by 6 is 2. So I'm going to say plus 2 times x minus 2 to the power of 3. And that's my final answer. Box it. Example number 4. All right, it tells us a function, and it's asking, it's not asking for the entire Taylor polynomial, it's just asking for us what is the coefficient. And I don't even need to do the first 4, I just need to do the 5th one, which is going to be this one. Again, this is the first term, second term, third term. The third term is 2, which means I'm looking for the 5th term right here. You always do one more, right, in terms of the number of terms that it's asking for. But this one's pretty straightforward because essentially, if I'm looking at this is a power of 4, if I'm kind of skipping stuff, so it's dot, 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 I really have x minus 1 to the power of 4, which means I'm going to be dividing by 4 factorial, which means I also have to do 4 derivatives. So this is going to be f to the 1, 2, 3, 4 derivatives, and I'm plugging in 1. So I don't care about this term anymore. I just care about what number is that, because that's going to be the coefficient. So 4 factorial, that's pretty straightforward. That's going to be, I should just say, this denominator right here is going to be 4 times 3 times 2 times 1. 4 times 3 is 12. 12 times 2 is 24. So the denominator here is something is 24, and then we just have to figure out this 4th derivative. If they ever give you this type of problem, they should make the derivative really easy to do. Otherwise, this is just kind of cruel and unusual punishment here. So here's the non-derivative. So I'll say f of x, I'll rewrite it, is x to the power of 5 minus 4x to the power of 3. The first derivative, the 5 comes down, it's going to be 5x, go down to power to 4, minus this 3 times 4 is 12x squared. Okay, take the derivative again, f double prime of x is equal to 4 times 5 is 20, so 20x to the power of 3. And then 2 times 12 is negative 24x. Getting there, this is f triple prime now of x is equal to, so 3 times 20 is 60x to the power of 2 minus 24. Again, when it's just x, the x disappears. And finally, f to the 4th, there's 4 derivatives now of x is equal to 60 times 2 is 120x. And then you plug in 1. So plugging in 1 times 120 is 120, which means this term right here is 120. Let me write that in green. This term right here comes over here and is equal to 120. So my final answer is, what is 120 over 24? And I just have to figure out what that number is. The top and bottom are both divisible by 4, so top divided by 4 is 30. The bottom divided by 4 is 6. Oh, they're both divisible by 8 then too, weren't they? Because I can divide by 2 yet again. Divide by 2, it's 15 over 3. And oh my gosh, 15 over 3 is 5. Is that right? Let me check. 120 divided by 24. Oh, yeah, the answer is 5. So the coefficient of that term is 5. Final answer. All right, I know that those notes were kind of long and that Taylor polynomials are kind of complex. There's the lesson. If you guys have questions, just ask me. That concludes AP Calculus BC Lesson 4-5. I'll see you guys tomorrow.